power rule. So we'll look at situations dealing with powers in algebra and kind of the different rules that arise out of them. So for the first one, I'm going to write this out in like full expanded form. What I mean by that is if you think about what x to the power of 3 actually is, it is x times x times x for this one here. And if we think about what x to the power of 5 is, that is x times x times x times x times x. And we want to times these two together. Now you can see all of these have been times. So a shorter way of writing this is if we've got 3 being times together and it's x to the power of 3, but overall we've got 8 being multiplied together. We can just write this as x to the power of 8. Now for this next one here, I'm going to also write this one out in a longer form. So x to the power of 7 there's 7 along the top there, and then we're going to put 2 along the bottom. Now, one thing we need to know for this is what is, I'm going to give you some examples down the side here. 5 divided by 5, we know that is equal to 1. We know we could have 900 divided by 900, and that would also equal 1. So if I had x divided by x, that must too also equal 1. So we can see, look, we've got some x divided by x's here, which is essentially just 1. So that's like a 1, and that's like a 1. So that's like 1 times 1. And you know, when we times anything by 1, it just stays the same. Like the number doesn't change, or the term doesn't change. So often we don't actually write times by 1 because it's not necessary. So what you can see here is we've got 1, 2, 3, 4, 5 x's left up on the top, which means this simplifies to be x to the power of 5, and then 1 times 1 on the bottom, which would be x to the power of 1, okay? So I could write, it could be just 1, sorry. But we don't really write things over 1. Like regular numbers, like if we think about 7 over 1 is just the same as 7. So we're not really that interested with having anything over 1, so we can kind of just ignore it, which means the answer is x to the power of 5. So looking over these first two rules, you can see these two here, add to make that one, and these two here, take away to make that one there. With this next one here then, we know that we can, if we're multiplying together, we're just going to add these powers. But the coefficients in front, they're dealt with the same way. So it's still going to be 5 times 3, which is 15, and 4 and 7, we multiply those together, it's going to make y to the power of 11. Now this last one here is a little bit different, because it's, look, a power to another power. Now what squared means is just times by itself, essentially. So we've got 3y to the power of 6 times 3y to the power of 6. That's an equivalent statement there. That times itself, same as squaring it. Now we've just done one like this here, and we know 3 times 3 is 9, and we also know that 6 and 6, y to the power of 6 times y to the power of 6, makes y to the power of 12. So what we can see here is, look, we deal with numbers like we normally deal with numbers. If there are a coefficient in front, we square it. And for this one, look, 6, 2, make 12. So 6 times 2 equals 12. So when we're multiplying terms, we add the powers. When we're dividing terms, we subtract the powers. And when it's a power to a power, we multiply it.